Now let us see the definition of a function. A relation from set A to set B in which each element of set A has a unique image in set B is called as a function from A to B and is denoted as f colon from A to B. So here we see a very important concept in mathematics, that is the concept of a function. And if we see the definition, the function is basically a relation between two sets, that is say from set A to set B, but with additional condition, that is each element of first set has a unique image in set B. So here the two underlined terms have a high importance, because we must understand that how it is slightly different from the definition of an ordinary relation. So as an example, here we have two sets A and B as shown in the diagram. We can see that each element of first set, which is A, has some image in set B. So we can see that 1 has image 2, 2 has image 4 and 3 has image 6. So it satisfies the first half of the condition, that is each element of set A. Now that has a unique image in set B. So by unique we mean there are no two different images of a particular element in first set. So that means if we have something like this, say element 1 has two images 2 and 4, then that is not allowed in a function. Alright, so that is what is the meaning of having a unique image in set B. So let us see some of the examples based on this definition of a function. Here the question is, identify which of the following relations are functions. So we have to recollect the definition of function and then answer accordingly. Now if we see the first relation R1 is given as 1, 2, 2, 5, 3, 10 and 4, 17. Now suppose we want to depict this graphically. Here we have two sets. First set contains the elements 1, 2, 3, 4, because if you see the first elements are 1, 2, 3 and 4. Alright. Now if we consider the second set, it will contain the elements 2, 5, 10 and 17. So 2, 5, 10 and 17. And if we join the arrows, which is the relation given to us, now we have to check whether this relation is a function. For that, let us recollect and verify the definition of function, that is each element of first set has a unique image in the second set. So that means if we see that all elements of first set have a single image in second set, so therefore the answer is that yes, this relation is a function. Right. Now let's see second relation, that is R2. Now this also is given as a set of 5 ordered pairs. So let's try to draw the picture for that. Now if we observe all first elements, we have 1, 2, 4, 3, 2. Right. So in all we have basically only 4 different values of the first element, and that is nothing but 1, 2, 3 and 4. Alright. So let us write those values in the first set. So that is 1, 2, 3 and 4. Alright. Now let's look at the values of all second elements. That is nothing but 1, 3, 2, 1, 4. So here also we see that the total values that are visible here in the example are 1, 2, 3, 4. Alright. Now we have to join the arrows and depict the given ordered pair. So first is 1, 1, second is 2, 3, third is 4, 2, then we have 3, 1, and then we have 2 comma 4. So this is the relation given to us. Now let us ask the question whether each element of first set is covered. So the answer is yes. We see that all the elements have some arrows attached with them. Now the second part of the condition is, does each element have a unique image in second set? Now if you see element 1 which has a single image 1 in that. If you consider element 4 which also has a single image, say 2. If you consider element 3 that also has a single image 1, alright. But if you consider the last element, that is 2, you see that it has 2 images in second set which are 3 and 4. So therefore this violates the second part, because any element in first set cannot have more than 1 image in the second set. So therefore, since the definition is not satisfied, this given relation is not a function. So it is just a relation, right? And lastly, let us see the third question. Now here the diagram is already given to us. Here we see that there is 1-to-1 relationship between 1, 2, 3 and respectively 10, 20, 30. Now here whatever elements are there which are in relation, those have a unique image, so that is satisfied. But we observe that there is one element in first set which does not have any image in second set. So this violates the first part of the condition mentioned in the definition of the function, right? As we want each element of first set to have a unique image. So therefore, since it is not satisfied here, this relation is not a function, alright?